All right, let's go ahead and get started. So there are 7 of you here today, but the funny thing is it's the most important 7 of the whole class. So it's great how that worked out. So we're going to jump in on page 50. A quick look at the calendar shows us that today we are talking about something called the product and quotient rules, and then in the activities you'll spend some time reviewing some pre-calculus functions, powers, polynomials, and rational functions. Pointing out on the calendar also that the quiz, which was the take-home, is due right now, so put the quiz, oh, we're making a super table over there, I like it. So put the quiz in the folder if you haven't done so already. The quiz is one of the few things I will ask you to not talk to your neighbors about, especially because not everybody has taken it just yet. So please don't talk about the quiz until Wednesday. I'll give it back to you then. And also coming up next class, Wednesday, the arbitration project is due. And then Friday, the trucks project is due. Okay, so later this week, both projects are due. I do accept them late. I don't remember what the lateness penalties are, but it says it in the syllabus what they are. So better to turn it in on time, but better to turn in late than not at all, okay? So hopefully close to finishing each of these 2 things. All right, at the top of page 50, we'll get a reader, but I crossed off some stuff that shouldn't have been here in the first place. So let's go to Ryan for the summary.
In this class, we learned 2 more derivative functions. And we review these kinds of power, polynomial, and rational.
Okay, and the concept of continuity we talked about in a previous class. It moved from this day to an earlier day, but I forgot to take it out of the summary and the title. Okay, so first a notation reminder. If you see d over dx and then brackets, that means the derivative of what's in the brackets, okay? Again, we'll see that notation formally soon, but we're going to use it today anyway. So, number 1, Brendan. Okay, if they were nice, then what would the answer to this problem be? Okay, so this problem says take the derivative of that big fraction. So if life were good, then you could just take the derivative of top and bottom separately and put them in your answer. What's the derivative of 3x plus 2? 3. Over. What's the derivative of negative 2x minus 1? Negative 2. And that would be the answer, and we'd move on, right? That's how it would work if it were plus or minus. But unfortunately, it doesn't work nearly that nicely for times and quotients. So to convince you of that, I pulled up this web page, Wolfram Alpha. You should check it out if you haven't. It's awesome. It can do all kinds of math and science stuff. So I just typed in plain English, no worries about syntax, find the derivative of that thing. And so we hit equals, and it takes a moment to do some calculations for us. And it will tell us decidedly that the derivative is not 3 over negative 2. There it goes. Okay, so apparently the derivative of that thing is 1 over 2x plus 1 squared, not 3 over negative 2. There's a graph, there's more stuff below, but the important thing is it's just not as simple. I don't know where this came from, but it's definitely not what we were hoping it might be. Okay, so jumping down to number 3, we're going to talk about the product rule here, and then in number 5, the quotient rule. So the product rule says that if you want to find the derivative of f of x times g of x, that's the product of these 2 functions, you need to take f and multiply it by the derivative of g, and then you need to add g times the derivative of f. In other notation, f times g prime plus g times f prime, or the way that I remember it in English, first times derivative of the second plus second times derivative of the first. Can you guys say that last one with me again? First times derivative of the second plus second times derivative of the first. That is the product rule. Let's use it on number 4. It says find the derivative of this mess. First thing you need to recognize is that it is a product of 2 functions of x. Here are my 2 functions highlighted in different colors with the times in between. So let's use the product rule. It says first times derivative of the second. That means you literally copy the thing that's first. It is yellow. Okay, the next part of the product rule, that was first, times derivative of the second. times. Now we need to do the derivative of the second, which is highlighted in blue. So what's the derivative of 4x squared? 8x. Derivative of minus 3x? Minus 3. Derivative of plus 8? 0. So this piece underlined in red is the derivative of the second. Any questions so far? That is roughly half of the product rule. The next thing in the product rule says plus. Plus. Continuing in the product rule, second times derivative of the first. Second, you just copy it. It's highlighted in blue. 4x squared minus 3x plus 8. Times, so another multiplication, the derivative of the first. The first is in yellow. We need to find its derivative. What's the derivative of 7x to the 4? Let's hear from somebody else. What's the derivative of 2x cubed? 6x squared. Somebody not Brendan. Derivative of minus 5x? Minus 5. Look at all those not Brendans out there. And then the derivative of the minus 1? 0. Well, that right there, my friends, is the derivative of the original, and it's our first application of the product rule. Any questions on any of the pieces? The product rule is by far our most complicated derivative rule so far. First times derivative of the second plus second times derivative of the first. It's got 4 distinct pieces. Any questions? Okay, if you wanted to, you could distribute each of these things and combine like terms. I don't want to. The calculus piece is done. Okay, so I said the product rule was by far our most complicated derivative rule. Okay, now it's not going to be the most complicated derivative rule because the quotient rule is even messier. So if you want to find the derivative of a quotient, f over g, you do g of x, that's the thing that was on the bottom, times the derivative of f of x, the thing that was on top. Big difference here between the product and quotient rules. What's that symbol? That symbol right there. Subtraction, which is very different from the symbol in the middle on the product rule, which is addition. Okay, f of x, you're copying the top, times derivative of g, that's the derivative of the bottom, and then all of a sudden from out of no place comes this denominator. It's g of x, the whole thing squared. Whatever was downstairs gets squared. Okay, in slightly more compact notation, g times f prime minus f times g prime over g squared. But I can tell you that I remember neither of those formulas. I remember this thing that's in bold. Bottom times derivative of the top minus top times derivative of the bottom over bottom squared. With me? Bottom times derivative of the top minus top times derivative of the bottom over bottom squared. All right, we're going to work on our timing later on, get some practices. Okay, so let's try finding the derivative of this guy. This was our original thing. Derivative of 3x plus 2 over negative 2x minus 1. So first, we have to recognize that the quotient rule is in play because the thing we're taking a derivative of is, what kind of a thing is that? It's a division. It's quotient. So that tells you have to use quotient rule. So the very first thing I do with the quotient rule is make a big fraction and put the bottom because it's really easy to get lost in all the stuff on top and forget that there's a denominator. Page 50, Kevin. So what goes downstairs is the bottom squared. So you take whatever you had, negative 2x minus 1, throw it in parentheses, squared. That's the new denominator, and that's always what I do first. It's easy to forget to do that if you wait until the end. Okay, so now we're going along this bold-faced thing. It says bottom times derivative of the top. Now underline here, bottom, bottom. This is a copying thing. What's the bottom? Negative 2x minus 1. Next word I see is times. Times. We'll go green here. Derivative of the top. That's what we got to put here. What is the derivative of the top? 3. Super. Sometimes the derivatives are more complicated. This one is pretty easy. True. Next thing, minus. Minus. And then we're doing top. Let's do this guy in purple. So right here, we're trying to do the top. What's the top? 3x plus 2. Copied down. Bring in parentheses. Times. And then we'll underline here in black, the derivative of the bottom. So right over here, what's the derivative of the bottom? -2. That's the derivative. Any questions on any of those pieces? Okay, let's clean this up a little bit. The calculus is done, but let's do a little bit of algebra and see if we can get this to look like the answer Wolfram Alpha gave us. So let's distribute the 3 and distribute that -2. Just be careful with those 2 minus signs. There's a subtract and then the -2. And upstairs, I think lots of stuff goes away. I just get 1. I get that upstairs? Plain old 1. Any questions on any of that? Okay, one word of caution. It is tempting to take the 2x minus 1, minus 2x minus 1 in red and cancel it with one of these guys down here, right? Because it's squared, so maybe there would just be 1 left over. Is that okay? Why not? Yeah, there's a subtraction sign up there, and this 2x minus 1 squared is underneath both things upstairs, and you can't just get rid of it underneath 1. And the real problematic thing is that every time you do the quotient rule, you're going to have this temptation in front of you just by the way the quotient rule works. Look at it. There's a g, and there's a g squared. You're always going to see that thing that might tempt you to cancel, and it never does. If it did, we would have made the quotient rule look a lot simpler than it does right now. So don't cancel. Okay, and does this final answer look like what Wolfram Alpha said? Let's see. They say 1 over 2x plus 1 squared. Is that what we got? Yeah, we had minuses in front here. They did something kind of funny where they factored the minuses out, but then it was squared, so it just became positive anyway. And this is what I'm expecting as your answer, but it's equivalent to what Wolfram Alpha says. Okay, and then the last thing is this piece, which I think is brand new notation. Again, we'll talk about it formally soon enough, but any guesses as to what that new thing means with the x equals 4? That's it. Take the derivative first, and then plug in 4 for x. So let's do that right over here. So what do we get? 1 over -2 times 4 minus 1, and that's squared. One over 81. Okay, so product rule, quotient rule. We'll have opportunity to practice both of those on the very next page, which is where the activities start. Let's see how far we can get.